Okay, systems of equations with 3 variables. Take really, really, really good notes on this, please. Okay, I'm obsessed with SpongeBob for some reason. Like, I grew up watching SpongeBob, and I don't know, I'm just obsessed with it. But anyways, so a linear equation, which we did last time, can be 2 dimensions, so such as an x and a y. 3 dimensions makes it a plane. 4 dimensions makes it like, honestly, dimensions really confuse me. So in math, you can go up to infinite dimensions. So I'm in this class that we can do math with like the 100th dimension, but physically and like my brain as a human cannot understand what the 100th dimension is because we live in a 3D world. Maybe 4D if you count like time, I guess. But like what is the 100th dimension? Like, is there a place out there that has 100 dimensions? Like, you can just go in this spiral of thought. It's kind of crazy, but there's math to back this, which means that there's probably, math describes the world, which means there's got to be a place out there that has 100 dimensions, but like, what is it? Can we just not perceive it? I don't know. Anyways, okay. So these are different examples of what our 3 variable systems of equations can look like, where each of these planes represents one equation. And the place that they cross, the point that they cross is our solution here. Because there's one point where they'll all cross. Or there might not be. Like, for example, if we look at this one, those are never going to cross, right? So that one would have no solution. Whereas this one, they have a line right here that looks like they're crossing at. So that one would have a solution of y equals blah, 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 some line. Same, like there's just lots of different things that this could look like. And we're going to focus on ones that mostly look like this. Okay, so let's look at this equation right here. And this, if you go to this website, it's really cool. You can put in these equations and it will bring up planes for you, and you can kind of mess around with what this might look like. So if you ever want to, go to geogebra.com and there, or .org, and there's a calculator on there you can use. But, so we have 2x minus 6y plus 9z equals negative 8, and 5x plus y plus 2z equals 10, 3x plus y minus 8z equals negative 28. So that, when I put it into GeoGebra, that is what it looks like. So we need to find the point that all of these are crossing. And it looks like it's probably about right here. Probably. I don't know. Okay. It's kind of hard to tell off these pictures. But let's go through how to find this. So the first step is to label each equation. And follow these steps. I promise it will help you. And keep yourself as organized as possible. So label each equation. So that's going to be equation 1, equation 2, and equation 3. Now, I did them color-coded. You don't have to, but it just kind of helps to see the visual thing. Now, we need to choose a variable to eliminate, and we have to stick with it. Once we choose our variable, you're stuck. You cannot change, okay? So I'm going to choose to eliminate the y's right here. And I mostly did that because, like, see how we have this one, the y and the y? Well, that makes it a little bit easier to just eliminate those. So we've chose our variable. Now we're going to choose 2 equations and eliminate the variable. So I'm just going to take equations 1 and 2 right now. Now to eliminate this variable, I need to multiply that blue equation by 6. And we'll get 30x plus 6y plus 12z equals 60. And I just rewrote the purple equation. Now, if we add these 2 equations together, the y's are going to cancel. And I'll be left with 32x plus 21z equals 52. And I am going to call this equation number 4. Okay, it really helps to label your equations. Now, I need to go back because I only used equations 1 and 2. I haven't used 3 at all. We have to use all the equations. So we have to use the equations that we haven't used and one that we already did use, and we have to eliminate the same variable. So now I'm just going to take equations 2 and 3. And I'm going to multiply either one of these by -1. It doesn't matter. I just need that to be the opposite sign. So then that's going to be -5x minus y minus 2z equals -10. Then the green equation is 3x plus y minus 8z equals -28. Now we can add those together. The y's are going to cancel, and I'm left with -2x minus 10z equals -38. And I'm going to call that equation number 5. Okay, once you get down to equation 4 and 5, you should have the same variables in each of these equations. They both have an x and a z in there. So we're going to put equations 4 and 5 together, and we're going to solve that system. So that's going to be 32x plus 21z equals 52, -2x minus 10z equals -38. Now I'm going to solve this by elimination, so I'm going to multiply that bottom equation by 16 to make that a -32. So then that becomes -32x minus 160z equals -608. Add those together, the x's cancel, and I'm left with -139z equals -556. Divide by -139, and we get z equals 4. Now, I will never give you one that doesn't end up in a whole number. So if you get a fraction, you get a decimal, you did something wrong, you need to go back and check your arithmetic, okay? So z equals 4. And then once we have one of these variables, this starts to break down pretty easily for us. Now, I'm going to substitute that answer into equation 4 or 5. It does not matter which one, just one of those equations, because then I can solve for that other variable there. And I chose to plug this into 5. So I have -2x plus 10 times 4 equals -38, which is -2x minus 40 equals -38. Add that 40 over and you get -2x equals 2. Divide by that -2 and you get x equals -1. Okay, and then last step is to substitute your two solutions into equations 1, 2, or 3 to find the final variable. So I chose the second one, doesn't really matter. So I have 5 times -1 plus y plus 2 times 4 equals 8, which that's -5 plus y plus 8 equals 10. So that's y plus 3 equals 10, so y equals 7. Now, when you're putting this as a point, alphabetical order. Just put it in alphabetical order. So that's going to be -1, 7, 4. That's one solution. Okay, let's do another one. So 4x plus y minus 3z equals 45. 6x minus 4y plus 3z equals 41. 2x minus 7y minus 11z equals 85. So I graphed these, and it looks like that. So we're trying to see where these planes cross each other. And there's our steps. So the first thing you do is label each equation. So 1, 2, and 3. Now I have to choose which variable to eliminate. And this time I chose to eliminate my x's. Now remember, it does not matter which variable you choose. They will all work. You will all end up at the same spot. Okay? So I'm going to use equations 1 and 3 first. And I'm going to multiply equation 3 by -2 to make that a -4. So then I get -4x plus 14y plus 22z equals -170. Then 4x plus y minus 3z equals 45. So those 4x's cancel, and I have 15y plus 19z equals -125. And that is going to be equation 4. Now, I haven't used equation 2, so I have to use equation 2. And I'm going to use equation 2 and 3. And I'm going to multiply equation 3 by -3 to get that to be a -6. And that's going to be -6x plus 21y plus 33z equals -255. So those 6x's cancel, and I'm left with 17y plus 36z equals -214. And that is equation number 5. Now I'm going to put equations 4 and 5 together. And these might look kind of ugly. So 15y minus 19z equals negative 125. 17y plus 36z equals negative 214. Now these numbers are going to get really big, but then they're going to get small again. So I am going to eliminate probably my y's here. So I'm going to multiply that top equation by 17 and the bottom equation by negative 15. Just to get them to be opposite signs, okay? So if we multiply the top equation by 17, I end up with 255y plus 323z equals negative 2,125. And then 17 times 15 is negative 255y. 36 times negative 15 is negative 540z. And then equals 3,210. Those y's cancel. And I'm left with negative 217z equals 1,085. If you divide by negative 217, you get z equals negative 5. Now I'm going to plug that into equation 4 or 5. Doesn't matter which one. I chose 4. So that's 15y plus 19 times 5 equals negative 125. 19 times 5 is negative 95. Add that 95 over, and I get 15y equals negative 30. Divide by 15, you get y equals negative 2. And then to get the last variable, I'm going to plug it into one of the very top equations. So it's going to be 4x plus negative 2 minus 3 times negative 5 equals 45. So that's 4x minus 2 plus 15 equals 45. So 4x plus 13 equals 45, which means 4x equals 32. So x equals 8. So we put them in alphabetical order. We have one solution of 8, negative 2, negative 5. Let's do one more. This is the last one, I promise. So there's our equation. So 5x minus 3y plus 8z equals negative 59. 9x minus 4y minus z equals negative 60. And 5x plus 2y plus 4z equals negative 47. That's what those planes look like. So then we label our equations. And we choose which variable to eliminate, which I probably eliminated the z's here. So then I'm going to look at equations 1 and 2, and I'm going to multiply equation 2 by 8. So then that becomes 72x minus 32y minus 8z equals negative 480. Now if we add those together, those 8z's cancel, and I'm left with 77x minus 35y equals negative 539. And that's equation 4. Now I used 1 and 2, so I have to use 3. So let's do 2 and 3. You could have done 1 and 2 just as easily here. So I'm going to multiply equation 2 by 4. And that's going to leave me 36x minus 16y minus 4z equals negative 240. Now those 4z's cancel. I'm left with 41x minus 14y equals negative 287. And that's equation 5. Now we can put equations 4 and 5 together. And we need to choose what to eliminate. Let's probably eliminate our y's. They're a little bit smaller. So I'm going to multiply that top equation by 14. And I'm going to multiply the bottom equation by negative 35. Since they're the same sign, we need to make them opposite signs. So I just have to choose one of them to multiply by a negative. Which the top equation becomes 1078x minus 490y equals negative 7,546. The bottom equation becomes negative 1,435x plus 490y equals 10,045. So those y's cancel, and I'm left with negative 357x equals 2,499. Divide by that negative 357, and you get x equals negative 7. It will always end up as a whole number. If it doesn't, something went wrong, you need to go back. Okay? Then we can take that, plug it into equation 4 or 5. So I have 41 times negative 7 minus 14 times y equals negative 287, which that's negative 287 minus 14y equals negative 287. So negative 14y equals 0, which means y equals 0. Now I'm going to take those two and plug it into one of the top equations. So I have 5 times negative 7 minus 3 times 0 plus 8z equals negative 59. So that's negative 35. The 3 times 0 just gone. Plus 8z equals negative 59. Add that 35 over and you get 8z equals negative 24. Divide by 8 and you get z equals negative 3. So we have one solution here. It is negative 7, 0, negative 3. The biggest thing with these is to stay organized. Stay as organized as possible. Okay? I'm done. Goodbye.